Hello, didn't we talk about these? We did the first one, and then did you try the second one? Remember I was saying it's halfway in between? Hello? Hello? Exactly. Halfway in between, because the 5, it means it's perfectly between negative 1.32 and perfectly halfway between negative 1.33. So you find the two probabilities on your z-table, add them together, and then divide by 2, and this is what you get. So add that plus that, then divide by 2, and that's your p-value. Okay? And then I obviously didn't state whether or not you reject the hoe or fail to reject the hoe. Okay? The null. You know what I meant. All right, did you check those z-scores from the chart? Okay. Well, probabilities, not z-scores. Okay. So what does that tell me if the p-value is 0.0926? So I'm going to put 0.0926. We always put the p-value first. Then we put a box. Then we put alpha. 0.05. And what goes in the box? 0.09. That is greater than. So we fail to reject the null. Yep. Okay. All right, there was one more. Have you had time to try that one? Go for it. Okay, so this one says does not equal to, which means it's a two-tailed test. Okay, and when you plug it into your formula, you would have 11.52 minus 12.4, right? Yes. Right? Then you would divide by 2.2 divided by the square root of 16. And that should give you a z-score of negative 1.6. All right. So now we find the probability that z star is less than, whoop, not equal to, I apologize. The struggle today, team. Ugh. Less than, okay, and this one's a two-tailed test, so that's kind of like the ones on the homework that I was talking about, right? So you have to think about where would negative 1.6 be? To the left of 0. The standard curve always makes that a 0, yes? So negative 1.6 would be here. So that value you're finding on the chart would be this, right? Because your z-table always shades to the left. And it's a two-tailed test, so we're going to take this number and multiply by 2 because we would have two tails the same size. If I'd got a number like you did on the homework on that one above 0, we don't want this whole big area, right? So that's why we would subtract by 0 from 1, right, to get this. I don't know why I started to say 0. From 1, and then we multiply that number by 2. So it really is all about the z-score, but because that's negative, we're good. And we get 0.0548. Okay, and then it's a two-tailed test, so I'm going to take that number and multiply by 2. And you get your p-value of, yes, 0.1096. And we compare that to alpha, which I said for all of these is 0.05. And that number is greater, obviously. So you failed to reject the null. Okay? Make sure you're putting the null here, everybody, on several of your homeworks. Remember I said what, failed to reject what, or you rejected what. Okay? All right, do this last one, and you're using an alpha of 0.05 for it as well. Okay? We're confused with the tails. Well, that's why the very beginning of it is one of the most important things you'll do. It says the Brown Agency has developed a new test that is quicker and easier to administer and therefore less expensive. Brown claims that its test results are the same as those obtained from the Kelly test. Many of the companies are considering a change from the Kelly Agency to the Brown Agency to cut costs. However, they are unwilling to make the change if the Brown test results have a different mean value. So the person would be the researcher. An independent testing firm tested 36 prospective employees with the Brown test and got a sample mean of 79. So what are they worried about? It not being the same. So the null and the alternate would be mu does not equal 82. which means this would be mu equals 82. And normally right here I have y'all put alpha, but I wrote it right there. So, okay, don't be judging that 8. All right, so this tells me it's a two-tailed test. Okay. And then your z star, use the sample mean of 79 minus 82 over 8 divided by the square root of 36, and you get negative 2.25. That's below the 0 on the standard score, yes. So I'm not going to have to subtract from 1. No. So when you look at that p-value, p of z star less than negative 2.25, that just gives me 0.0122. Good. But multiply that by 2. And that is your, what? I missed a 0. That's something that's so easy to do. It really is, and it can throw off lots of stuff. You know what I mean? All right, so 0.0244 is my p-value. And I compare that to alpha of 0.05. And it's less, so we reject the hoe. Just put reject H sub O. Do not write the word the in there. Please no. Just reject the null. You write null? That's fine. Okay. So for this to be fully finished, we've stated our decision. Now we have to state our conclusion, which means there is or is not. If you reject the null, there is sufficient evidence or there is not sufficient evidence? There is. There is sufficient evidence at the, yeah, you make sure that you say your level of significance in there. 0.05 level of significance to show that the mean test score what? Good, is not 82. Because whatever you wrote in your alternate is what you put right there. Questions? All right, the last thing, there's advantages for using the p-value approach. I'm getting ready to teach you what's called the classical approach. The advantage of the p-value approach is that the results are expressed in terms of a continuous probability scale. So rather than reject or fail to reject the null, you're talking about a probability, okay? The p-value is used to decide on the strength of the evidence. Remember, the smaller the p-value, the stronger the evidence against the null. Did you hear me? The smaller the p-value, the stronger the evidence against the null. And then computers can do these calculations, which eliminates the need for tables, okay? A disadvantage, this is important. A disadvantage is that some people have a tendency to put off determining their level of significance. Why is that a disadvantage? Hello? I'm doing pretty good. I'm waiting for the answer to this question, but why is it a bad thing, the tendency to put off determining the level of significance? You can't reach a conclusion without it? What'd you just say? You want to prove it? So let's say I collect my data, I get my sample, I'm making a statement about average height of high school teenagers, right? And then I wait to see what my p-value is before I state my level of significance. Why is that not a good thing? No, but I like that you're thinking about it. Couldn't I dictate my results based on what I want to prove? Couldn't I wait to see what the p-value is and then say, oh, that's less than or bigger than 0.05 but less than 0.1, so I'm going to make it 0.1 so I can reject the null. You see what I'm saying? So that's why, to add credibility, that's why I always have y'all first saying, after you state your null and alternate, state your level of significance. That way there's no question. And 2 years ago, we had a senior here at Gov School And Miss Callie was helping her do the statistical part of hers. And Miss Callie said, she got this p-value. Look how close that is to 0.05. I said, yeah, but it's a little bit bigger. Yeah, but it's so close. I'm like, I know, but if she said she's using 0.05, not 0.01, then she has to fail to reject, even though it was so close. And if you fail to reject the null, it means she had to say there wasn't sufficient evidence to show her alternate. You know what I mean? So you have to be careful. It's not a good thing to try to be sneaky and say, "Ooh, I'll just do it at the end," because then, it means it's not credible. You know what I mean? Does that make sense? All the other reasons, though, are why the p-value approach, it's a good thing, but that's one for why it's not a good thing. Okay, there's something else called